Go. This is lesson 1-5, and we are talking about parent functions and the transformations of those functions. And here is an example. Today is October 8th, Monday. All right, now, lesson 1-5. Okay, the parent function of this is a parabolic function, which would be f of x equals x squared. And notice how this is different. F of x equals negative 1/15 x squared plus 4x plus 1. Now, we're going to talk about how to see the transformation. And obviously, A is what? Because it's opening downward. Negative, that's correct. A has got to be negative. See how A is negative 1/15? Okay. Now, it technically, if you moved in increments of 1 for this, it would look a lot different than this, because it would look a lot flatter or fatter or something. But they've put it on here so you can see it better. But we're going to go over, and you have done it in Algebra 2 before, of how to turn this into work form, or I think this book calls it vertex form. And you can see talk about the transformations, okay? But we will do that, not at this moment. Okay, we have a lot of vocabulary, and it says new, but it's technically not. We have parent functions, constant functions, zero function, identity, quadratic, cubic, square root functions, reciprocal functions, absolute values, step, greatest integer. Those are all types of functions here that I would need you to be able to identify what type it is. Then we're going to talk about transformations, and which you have done before. Translations, reflections, dilations. Okay, all stuff that is going to be so much fun. All right. Now, so a family of functions is a group of functions with graph that display one or more similar characteristics. So a parent function has the simplest form of the function, and here are the types. How'd it go?
Pretty well. She had me run an errand while she was making copies. That's why I took
Just put that on my desk. It's fine. I'm using a student one, so it's fine. Okay, so here we go. A constant function is one that is a y, or f of x equals a letter, some number. Let me see. You know what? Let me turn that on and turn this light off and see if that helps us a little bit. Can you see it better? Mm-hmm. Okay. Now, so we have a constant function in the form, remember, f of x can be interchangeable with y. So f of x equals c. Y is the equation. F of x represents the function at some value x. Okay, where c is any real number. So this is x equals c. We could have, not x, f of x. Y equals 1, y equals 2, y equals 97, doesn't matter. Okay, now, and it's a horizontal line. When c is 0, then f of x is called the zero function. And that would be right on the what axis? X-axis, that's correct. Okay, good. Now we have the identity function, and that's just where the y equals x, or f of x equals x. So no matter what x is, y is the same thing. All right, and it has at a 45-degree angle, and it's a constant function. Now, and then it's pretty much the parent graph to direct variation. Because remember, direct variation always crosses at 0, 0. Do you guys remember that? It's been a minute. We'll get to it, but anyway. Okay, then we have quadratic functions. So f of x equals x squared has a U shape. This is a parabolic shape. You guys hopefully remember all of these. Okay, then we have the cubic function. So it has an odd exponent as the leading coefficient. We're going to have in behavior that goes in the opposite direction. But this is the most basic one. This is the parent function, okay? And you will be having a quiz over different types of functions. So, and you will not be able to use cards or foldables or notes or whatever. So it's good to make them and be reading over them, often, so you can be really familiar. Okay, now we have the square root function, and let me see if I can make this a little bit bigger. Okay, the square root function has the form of f of x equals the square root of x. Okay, now in this case, technically, that would be like a parabola would go up like this, and a f of x equals x squared, which would really be x equals y squared. That would be the graph that goes down here. But the problem with that is it's undefined, or it's imaginary down here, because it would have to be a negative number, right, for your, and that's, anyway. So that's why when we talk about f of x equals the square root of x, we're really only talking about this in quadrant 1, or wherever it's been transformed, but the parent graph being in quadrant 1. Okay, the reciprocal function has the form of f of x equals 1 over x. Here's the basic form of it, right? So if you find the values, you're going to find that it is undefined at x equals 0 and y equals 0. And so you're going to have these curves. And we've talked about that recently, you know, in behavior, what's going on out here, but also what kind of discontinuity. You guys remember what kind of discontinuity this is?
Removable.
It starts with an I. Infinite discontinuity, which is on page, I don't remember. Nice page number for you. Yes. It is on page 24. Okay, turn that pagina. Okay. Now, let's look at absolute value functions. Okay, so the absolute value function denoted by f of x equals the absolute value of x, you should remember that, is a v-shaped function defined as. So it's a piece function here, piecewise. So when x is negative for the parent graph, so anything to the left of 0, when x is negative, it's going to be the opposite of x. So that's what your graph is going to be looking like, the opposite of x. And when x is greater than or equal to 0, you only put the equal to with one of them. In this case, it technically doesn't matter, but x is greater than or equal to 0 because they're touching at the same point. So, or the limits are going toward the same point from either side, right? Okay, so x is going to be, or f of x will just be x. Kind of like, so there's your identity function, and it would have gone down here, but we flipped it up there because we're talking about absolute value. Everybody good? Okay, so here you go. Absolute value of negative 5 is 5, 0 is 0, 4 is 4, and they would be plotted points. Okay. And now, a piecewise defined function in which the graph resembles a set of stairs is called a step function. The most well-known step function is the greatest integer function. So it's the parent graph to our greatest integer function is this. F of x equals, now that's the double sum I've drawn on the board so you can see it a little bit better, but you should remember this. F of x equals the greatest integer of x, right? And those double bar-lined situations. All right, good deal. Now, using the tools you learned in Lesson 1.1 through Lesson 1.4, you can describe characteristics of each parent function. Knowing, when I do that it gets fuzzy. Knowing the characteristics of the parent function can help you analyze the shapes of the more complicated graphs in the family. Okay, so that is the idea that we need to do, is to analyze what's happening to the graphs. You're going to need and be expected to know how to do that. Okay, let's look at this example. Describe the following characteristics of the graph of the parent function f of x equals the square root of x. So we need to cover the domain, the range, the intercepts. Sometimes you'll have both, sometimes you won't. Symmetry, if there is any, continuity, end behavior, and intervals on which the graph is increasing and decreasing. So these are the things you need to cover when you are describing the characteristics of a parent function or any function. You need to cover these things. Okay, so let's look at guided practice 1. So it says for you to describe the characteristics of the graph of the parent function of f of x equals the absolute value of x. I'm sorry, I'm running out of space on my table here. Okay. That just made it worse, I think. Sure did. Okay. Oh, my word. Even worse. I don't know why it looks so crookedy to me. Okay. Now, we have the absolute value of x, and so we need to describe the following characteristics of the parent function. So what's the domain of the absolute value of x? Now think about what that looks like. Who can describe what the absolute value of x, absolute value of x looks like? Parent function. F of x equals the absolute value of x.
Oh, describe what...
Yeah, help me draw it. What would I do?
1, 1.
Okay.
Negative 1, 1.
Uh-huh.
2, 2.
Okay.
Negative 2, 2.
What about this one?
Oh, yeah.
Okay, and then we were going to connect the dots here, right? Okay, so we have this V shape, and the vertex is at 0, 0. Now, let's talk about the absolute, what is the domain of this parent function? Who can tell me that? Sarah?
Are all positive?
Yeah, well, now the domain is are your x values, okay?
Or, wait, yeah, then
All real numbers, that's right. Okay, great, because it's going, whoa, I just missed, stink. Okay, it's going to hit every value in the real realm of, here's our graph. So this is our function here. So it's going to hit all x's, right? However, I think what you were thinking of was what is the range. So the domain can be written as all real numbers. What is the range?
Positive.
They're positive. Now, and what else? Including what? 0. So we could do this. 0, comma, to infinity, right? All right, now, the only thing you need to be careful here is if you're doing it the way, if you're doing it the fancy way like this, so let's say y such that, or f of x such that, f of x, okay, we'll do that. So f of x such that f of x is greater than or equal to 0, where f of x is an element of all real numbers. I think I did that right. I'm just not really used to the way that they do it in the book. That is really squishy. But anyway, the interval thing is just fine. Okay. Now, so let's talk about the intercepts. Where does this intercept the x-axis? 0. And where does it intercept the y-axis? 0. Okay, now the next thing is there any symmetry? Whoops. Yes. And what is it symmetric about?
Down the line, y equals, or x equals.
X equals 0. Very good. Yeah. So it's symmetric about that point. Now, it's not symmetric about the origin, or you could pick it up and turn it 180 degrees, and it would look like itself again. Because if we turn this 180 degrees, it would look like the thing going downward, right? Okay, continuity. What do you think about continuity here? I'll keep doing that. Sorry. Does this have continuity or discontinuity? Yeah, because you can draw this without lifting your pencil, can't you? Okay, in behavior. Okay, so, whoa, again. So as x approaches negative infinity, what's y approaching? Positive infinity. And as x approaches negative infinity, what's f of x approaching? positive infinity, right? Okay, good. And intervals in which the graph is increasing and decreasing. So, this graph is doing what from negative infinity to 0? So, what do you think? Coming in from the left, it's doing what from negative infinity to 0? Decreasing. So it's decreasing on the interval negative infinity to 0. And increasing, increasing on the graph from 0 to infinity. Now, let me make sure I'm getting that correct. Which I need to put, or do we not put it with either one? Oh, I'm looking. I was like, where's the answer? Don't have the teacher's manual, do I? I'll look back at that in just a little bit, okay? Because I want to try to get as much done as we can. This lesson is forever long. Okay. All right, let's go to translations now. Do you guys remember this stuff? Hopefully, because I know I'm going a little bit fast here. Okay, a translation is a rigid transformation that has the effect of shifting the graph of the function. A vertical translation is going to shift it where? Up and down. And of the function of f shifts the graph of f up or down, while the horizontal translation shifts the graph left or right. Horizontal and vertical translations are examples of rigid transformations. Okay? Now, let's look at this. So, if you have a function and you're adding k, adding some number, I don't care if you're adding a negative or adding a positive, remember that you translate the graph up or down the way you would think it would go. So if you're adding k, you go up. If you're subtracting k, you go down. Okay, you do remember this. Good. Okay. Now, the graph of a horizontal translation is within the function. You guys remember that? It's inside the parentheses of the function. Is the graph of f of x translated h units to the right when h is, well, in the form of x minus h. Okay, but when you see that, in other words, the easier way for me to explain it to you is whatever's happening inside here, it's going to go the opposite direction you would think. But the actual formula for this is f of x minus h. So in other words, if h is greater than 0, that means you're going to subtract. If h is 3, you're going to subtract 3. So you're subtracting 3 inside there, it's going to go to the right. Do you see what I'm saying? Gets a little confusing on there. Okay, and if you're like adding something, it's really x, say you're going to add 4. You're really saying x minus a negative 4, so you're going to go left. Just go the opposite way you think on the inside of the function. Easier. Okay. Now, let's look at this, but we have a nice little friend on the technology tip over here to the left. It says you can translate a graph using your graphing calculator under the y equals. Place an equation in the y sub 1, move the y sub 2 line, and then move to the y sub 2 line, and then press vars, arrow over to the right, enter, enter. This will place y sub 1 in the y sub 2 line. Enter a number to translate the function. Press graph. The two equations will be graphed in the same window. Yeah, go ahead. Give me one so making sure we can do it ourselves. Okay. Thank you, sir. Okay. Let's go here, and I don't know what classes last used these, so I don't remember who that was. It may have been you guys. I don't know. So clear out your list, and let's put in, it says, under the y equals button, place the equation. Okay, so let's do the absolute value of let's do y sub 1 equals the absolute value of x. So we need to